Hi, my name is Sheng and my student ID is EB20183. So now I'm going to start my presentation on calculation. So first, to find high input frequency, we need to find CI and also RTS first. So by using the formula, we will get CI equal to 40 PF. So next, this is the formula of RTHI, which is Rg equal to R1 parallel with R2. But since we need to find this, so we just use RTHI equal to R6, which is 1.5K. So next, by substitute all this value into the formula, we will get FHI equal to 2.65 mega. Next is about high output frequency. So by substitute all this value, we will get CO equal to 21 PF. So this is the formula for RTHO, but since RD is equal to unlimited, so we just cancel it here. So by substitute this FHO formula, we will get RTH. This FHO is from the equation, which is 10 megahertz, and we will get RTHO equal to 757.88. So here is the RTHO. Substitute this value and we'll get RD equal to 876.03 ohm. Next is about low frequency calculation. So FLS equal to 100 Hz, which we get from the equation. So by substituting into this formula, we will get ZCS equal to 159.15. So by using the AV formula, we can get the GM, which here same as the RD equal to the unlimited, so we just cancel it, and we will get GM equal to 2.64 milli. So here we substitute the value that we get from the previous into the formula, and here we get the RS equal to 274.45. So next we apply KVL to get this equation, which next we will find the R2 and also R1. So we do for the unknown, which is ID and VGS. So by using this formula, we can find VGS. So substitute a value from previous and we get VGS equal to negative 1.2434. Next, same as the ID, we substitute all the value that here from the equation, and here from the previous calculation, we get ID equal to 6.28 milli. Last, we substitute all the value calculation into the formula, and we get 0.48 equal to this same. So by using the ratio, so last we get R2 equal to 3 and also R1 equal to 122. So we divide by so we will multiply by 100, and this is our last value R1 and R2 for the simulation. So that's all my presentation. Thank you.
Hi, my name is Leong, number ID EB20023, and I am here to continue the demonstration, which is the simulation. Here is our circuit. So this is our JFET using the VP -6, and to get IDSS of 10 milli, we need to use this beta, which is 3.45 milli. And here is the source, the AC source, DC source for the JFET. The load is here. We have the capacitor for wire in, here, the capacitor for wire out here, and we have attached the parasitic capacitors here, CGD, CGS, and CDS, like this, and the resistors in the voltage divider configuration. Here you can see for our resistor values, which is done in the calculations. The first one, R1 12.2K, R2 300 ohm, and for RS is 876.03 ohm, and RD is 274.45 ohms here. Now we want to measure the input voltage and then the output voltage at the R load here. So input we put it here, output we put it here, measuring the voltage across R loop, which is R6. So we let it run. After that, you can see the graph. Let me put the cursor here to the input line. We get from the lowest point to the highest point, which is the rising edge of our AC input. You can see the delta Y is 220.27 millivolts. So if we take the cursor back to the second line, which is the output line, you can see here is the starting point where the energy is lowest, voltage is lowest to the peak. So here we see it is negative 408.69 millivolts. So that is, if we take a calculator, just now our number is approximately 220.5. We multiply it by 2 and then put a negative on it. It's negative 441 millivolts. Which is around the same here, but because there are many capacitors, so the number is approximately the same. And that's all for our demonstration. Thank you.